Hi, today we're going to talk about the Zerologon flaw that was recently patched by Microsoft. We're going to explore in a purpose-built virtual environment brought to you by LegaSec via the LegaCTF platform. LegaCTF is a project that allows individuals free use to virtual simulations for the goal of learning, exploring, and tooling around in simulated virtual environments using nothing but a web browser. Once we log into the LegaCTF platform, let's go ahead and create the Zerologon Micro Range. This flaw was patched by Microsoft in August. This company, Secura, has done a lot of intense research and really found excellent exploitation. The depth and breadth of which is outside of the scope of this video, so I do suggest you read their white paper to get technical depth of this flaw and the research they've performed. The long and the short of it is they identified a cryptographic flaw in the NetLogon remote protocol, which allows you, among other things, to manipulate the machine account's password in Windows domain members. And so what we're going to do is we're going to attack a domain controller and abuse this flaw for the purpose of understanding it. What we've done is we've loaded this exploit code for proof of concept from this GitHub on the attacking machine. We've also loaded up the latest version of Impacket that was updated 2 days ago with some specific tooling for this flaw. And then we're going to perform a DC sync attack. The DC sync attack usually utilizes credentials with the appropriate rights to masquerade as a domain controller in an environment and coerce a legitimate domain controller to perform a synchronization or a replication operation with it. And we can garner, among other things, the Active Directory usernames and password hashes for users. Let's launch into our micro range. What we have is a domain controller, a Kali Linux machine, and a Windows domain member. So let's go ahead and launch into our attacking machine and start getting a lay of the land. We'll log in with the username Kali, the password of weak password. And for good measure, might as well switch over and log into that domain controller as well. We'll log in the domain controller credentials. Now, again, this is using nothing but a web browser. Let's go ahead and get into our, let's go full screen in our attacking machine. First thing we're going to want to do is identify our network landscape. So we see that we're on the 172.16.5 network. Our IP address ends in .5. We're on a /24 subnet. So I'm going to switch to the root user real quick. And let's do some network mapping to do some discovery. I'm going to run nmap with tac n to disable name resolution. And we'll go against our subnet. This should go pretty quickly. We have identified ourselves. This is the domain member, which is not that remarkable, and we can obviously see that this is a domain controller, just based on the ports, protocols, and services. So let's get a little bit more information about this host, because we are going to want to understand what the Active Directory domain name is and the NetBIOS name of the host. There's a couple ways to do this, so I'm going to kind of cheat, and we see that this is a domain controller, so I'm going to assume that it's got a self-signed certificate on port 3389 for remote desktop. And if we connect to that, we should be able to simply identify the information that we need. So the certificate is signed by itself, and we see that the host name is New York, and the domain name is dmevals. So this is information that we need. So now, before we take advantage of the Zerologon flaw, let's move into the Impacket directory on this host and the examples. We're going to run the secret stump Python script. That is going to be what we use to perform a DC sync attack against a domain controller. The options we're going to use is just DC to attack just the ntds.dit file, and we're going to use no pass to pass in no password. And so the syntax we want to run is secret stump, just DC, no pass, and then we're going to use two single quotes, and in between there we're going to put the domain name, which is dmevals, / the name of the host, New York, then $. That signifies we want to use the machine account. We're not using a user account. We're actually trying to authenticate as the machine itself. And we're going to say at the IP address of the domain controller. Now, when we issue this command, as expected, we get a logon failure. We just tried to use no password to authenticate to this host, and it says no. So now let's abuse this flaw, the Zerologon flaw. So if we go back 2 directories in the CVE-2020-1472 directory that we have the we have the Python script. So I'm going to run Python 3 and then the Python script, which is from that GitHub, that is the exploit. And we see that the syntax for it is we need the DC name, which is New York, and the IP address, which is 5.2. So let's go ahead and run this. Python 3, then the Python script. New York is the name. 172.16.5.2 is the IP. So once we run this, exploit runs. And we see that it says the target is vulnerable, and it says it's changed the account password to an empty string. Well, that is fascinating. Let's see if it worked. So we're going to switch back to the directory of Impacket, and then we're going to run that DC sync attack again. Let's see if it's different this time. Well, we see that the response is different. We've actually gotten the username and password hashes, among other things, from the domain controller. So that's a pretty big deal, and we see that the exploits worked. At this point, you could be talking about looking at detective controls, and we could go look at the Windows event logs. If you or your organization is interested in having tooling and telemetry added into labs using your IDS system or your EDR agents, that's something we can certainly talk about. Now let's do a little proof in the pudding of why this is a problem. So I'm going to take the domain administrator NTLM hash. I'm going to include that colon. That's important. And I'm going to run a tool called WMI-exec. And that is using WMI to perform administrative tasks and get a remote command terminal on the domain controller. Because let's remember, right now, what is our IP address? If we run IPA, we see that our IP address is 172.16.5.5. And we remember the domain controller is 172.16.5.2. So I want to run WMI-exec against that host. And I'm going to say I want to use hashes, and I paste in, whoops, I need to go copy it again. I paste in this admin, this domain administrator hash from above here. And then I say I want to be DM evals administrator at the host I'm trying to log into. And I'm passing, this is a pass the hash attack. So running this command, we notice that I now have a Windows command prompt, and I am operating on the domain controller. If I run who am I am a domain administrator on this host. So real quick, I want to kind of just a little bit more proof in the pudding. We'll go into that domain controller, and we're going to open up Active Directory users and computers. I want you to notice that there is no user with the name hacked. And I'm about to change that. Now, obviously, a genuine adversary is not going to sit there and add a domain admin to the administrators group, but I'm feeling a little YOLO pen testy right now, just proving that we have complete control of this Active Directory domain. So net user, we'll say hacked, we'll give it a password, we'll say added to the domain. And then we're also going to say I want to go to the domain admins group. I want to take hacked, and I want to add that user to the domain. Both of those commands completed successfully. So if we go back to our domain controller, we notice that we have just added a domain admin user, and that is a problem. Domain admins, username is hacked, and just for the last kind of nail in the coffin, we'll go ahead and log into an Active Directory resource as that new user that we just created. So we can see that this flaw is brutal. Now do be careful and understand that messing around with Active Directory in an environment, production or otherwise, is dangerous. So that's why this exists. Hopefully this can help you in your research, and thanks for watching the video. Take care.